all of the three kind of models: class model, state model, and interaction models. Then today we will make a brief summary of all of these concepts. The three related but different viewpoints for the three kinds of models. The class models describe the objects in the system and their relationships. The state model describes the life history of objects, and each state diagram will describe the life history of one object. It means that for different objects, we have different state diagrams. And the interaction models describe the interactions among objects. And for the interaction model, we have three separate types of interaction models. The first one is the use case, the second is the sequence model, and the third is the activity diagram. First, for the class model describes the static structure of objects in the system. It describes the attributes, operations of objects, and in the class model, there are classes, associations, and the generalization. Generalization is a very important characteristic of objective-oriented modeling. It means that the abstraction of the hierarchical structure of different levels of classes, for example, the superclass or overridden or subclass. It means that for this kind of overriding inheritance, especially inheritance of different classes, it means that we can organize the different classes into hierarchical structures, and some classes with the common attributes or operations can be abstract into one superclass, and then the different other classes are called subclasses. They can inherit some important or common attributes or operations from the superclass. And this is the example of the class model. The state model describes the aspect of an object concerned with time. It means that we have three important concepts: events, states, and activities. In the state diagram, that for one object they have different states. The states are a kind of abstraction of different values for the attributes and links. And there are three kinds of events: signal event, change event, and time event. Signal event, it means that some messages are transferred between different for example, get some message, for example, key pressed, and so on. Change event means that, for example, some condition change. For example, previously the condition does not satisfy, then currently it satisfies. For example, when the time is equal to an absolute time, this is a kind of change event. And the time event means that, for example, for a specific interval of time elapsed after a specific time interval or equal to an absolute time. It's called the time event. And in different states, there are different response to different received events, and we will use some the state diagram to show their events and the activities for different events. Within the state, there were some do operations or do activities, or some activities are correlated with events. It means that when in different states, when it gets some events, it got different events, they will do different activities. For example, like this, there are states and the events and the activities. When in the closed state, when it received the deprice event, it will do the motor up. The third tab is the interaction model. It describes how objects collaborate to achieve results. Use case, this is use case. Divide the system into different pieces of functionality. Sequence diagram. Here, each vertical line is an actor of the system itself, and the horizontal arrow is a message transferred between different objects. And for the sequence diagram, it mainly focuses on the sequence of messages among different objects. The third tab is the activity diagram. It mainly focus on the flow of activities to implement some algorithm or workflow. And for these three kind of models, they all involve the same concept: data sequencing and operations. Each model describes one aspect of the system, but they all involve the data sequencing and operations. Some are the sequencing of messages, and some are the sequencing of operations. The data means the static data structure of the system of the class, and so on. And now we have studied all of the three types of models. It means that we have some tools to modeling a software. It means, so at first we should know the whole process of developing a software. So the development stage, it means the stage for developing a software. Usually we have these steps. The first is system conception, analyze, system design, class design, implementation, testing, training, development, maintenance. And in this course, we will mainly focus on the first three stages, and for the others, it's not within the scope of this course. And for the system conception, in this stage, we will have an idea for an application. We will consider the business needs, and it means why do we need to develop this software and some technical capacities. And for example, it means that we want to develop an electric car. We need to consider, okay, why do we need to develop this car? It means for people live in city, not in some remote village, because in the remote village it is electric car. We cannot usually the electric car can only run less than maybe 200 kilometers, so it is not suitable for the use in the villages. So, and we may consider give some basic requirements for the application. It means you should use green power, and should consume electricity, and it should contains a group of battery and can support for driving about 200 kilometers. This is some basic technical capacity. It means that before we developing a software, we should also consider this three kind. Means give some idea of the application. It means this is some idea for the application. Consume electricity, green powers ideas. It is the the needs and the business needs. It means for people in city, it's a business need. It means why do we need to develop this software and some technical capacity. It means can support the running of 200 kilometers. And for the second is the analyze stage. We will capture and scrutinize requirements by focusing on creation of models. It means that in the conception stage, we only using text to describe our requirements, and in the analyze stage, we will use the the models we have studied to describe the system, to build some efficient, reliable, and correct, to use these models to build an efficient, reliable, and correct application. And business experts are not sure of precise requirements usually. So we need to discuss with the business experts iteratively using the models we have built. And there are usually two sub-stages of analysis. The first is the domain analysis, the second is application analysis. In the domain analysis, we mainly focus on the objects and their relationships of objects with real-world counterpart. And in the application analysis, we will enrich the models built during the domain analysis by adding some application objects that can be seen by users. It means we only focus on the application objects which can be seen by users, and they are a little bit different with objects in which has in real world interpret. For example, in the domain analysis, when we are developing online taxi calling system, we may consider the tax car and so on. They all objects with real world counterpart. But in the analyze and application analyze stage, we may consider for example, the user interface of the apps, and these are the objects which can be seen by users, but they don't have real world counterpart. It means that we will building some models to analyze the system. And in the system design stage, we will make strategic decision to formulate on architecture. It means it is a high-level plan. We will, in the software, developing a software, we will design the architecture of the whole software and how to divide the system into different subsystems and how does it communicate with each other and so on. And in the class design stage, we will expand on and optimize analyze models by shifting attention from application concepts towards computer concepts. It means that it is a kind of designing the more detailed classes. We will choosing algorithms, choosing data structure, and design internal classes and operations for each classes. It means that we will consider we will consider some computer concepts. In this stage, we still don't consider how to implement it, but we should consider which kind of algorithms for use. For example, we have so many different kind of sorting algorithm. Which one will we use, and what kind of data structure will be used to store the results, and so on. And it means we will selecting appropriate algorithm, finding suitable data structure, and adding some necessary operations to the classes. This is a class design stage, but it is not implementation. So in the implementation stage, we will really